Alright, so we already learned what Java types are, and let's also talk about typecasting, which means converting a value from one type to another. So typecasting is when you assign a value of one primitive data type to another type. In Java, there are two types of casting. Widening casting, which is done automatically by Java, is converting a smaller type to a larger type size. And again, this will be done automatically. And here's the order. So byte to short, short to char, char to int to long are done automatically. So any of them to float or to double are also done automatically. So the other one is narrowing casting, which is converting a larger type to a smaller size type. Since there is a possible uh, data loss, so Java does not do it automatically, so we'll intentionally do it on our own. So let's see the order. So double to float is done manually, or double to any of the integer types, or integer to char, char to short, short to byte must be done manually. So how is this done? So let's see an example. Here we can see a double x, which we do set it to 3.14, which is perfectly fine. No casting is needed. However, if you assign an integer value to a double y, so double is this is not double and y is not integer, so we need to convert this to a double, which is 3.0, and doing so we will not lose data, so Java will do it for us. So if you are to print y will be 3.0. So here's another integer z is set to 3, perfectly normal, no casting needed. But if you are to assign z a value that is not an integer, for example 3.14, this will issue an error. So Java will not allow you to do this. However, we can manually typecast by saying set z to integer followed by a double value, which will the casting, which means we'll truncate the decimal part. We'll only keep the integer value, and we'll assign it to z. Z3 will be stored in z. Here's another example. You can create an integer t and assign x. Remember, x is a double, same value, 3.14, so you will need a manual typecasting. Alright, so let's work on a cast demo example. So I've already saved this to save some time. So I'm going to define a double d1 and d2, an integer i1, a char ch, and a byte b1, b2, and b3. So remember, integers is a 4-byte data type, char is an 2-byte, and byte is, by the name suggests, it's just 1 byte. So let's assign some values to b1. Let's make b1 10 and b2 3. So do you see the automatic typecasting is happening here? So basically 10.0 will be assigned to b1. So likewise 3.0 will be assigned. So we can see an automatic typecasting there. Then I can say I1 is set to x, keep saying x, okay, so d1 divided by d2. So you might say, hey, this is gonna issue an error. Correct, so we need to typecast, because a double divided by a double yields a double. So I need to typecast it to integer. But there's one more problem. This integer only applies to d1. So I have two options. I can say int d1 divided by int d2, which is a different operation. But what I really want to do is I actually do want to do the double level division, which I want to get the exact accurate result. Then I'm going to cast the result of this expression. So otherwise it will only do d1. So please be careful on that. So pl, then I can say integer value, integer outcome of d1 divided by d2 is I1. Okay, so ready to test. Java C cast demo. Okay, one problem. B1, B2, B3, B2 is already. Okay, I know what I did wrong. One more. Oh, D and D. Final time, there you go. Java cast demo. So the integer outcome of D1 divided by D2 is 3. Otherwise it will be 3.333 all the way to 15 decimal precisions. So next I want to do, so I have an, let's say I1 is 100. Then I'm going to assign B1 I. So here's my question, do you think this will work? Now what we know is B1 is a byte that can support any number from negative 128 to positive 127, and 100 perfectly falls into the range. However, this will still issue an error. The reason for that is integer is actually a 32-bit numbers set, and the byte is only 8. So which 8 that we're going to take is unknown. So I have to actually typecast this to byte. Although, even though we know that 100 can fit in without any problem. So, all right, so let's print this. Then we can say value of B1 in this case is B1. So I'm going to test, see that we get this right. Here we go. So correct. However, if I1, I'm going to copy the whole thing and paste again out of laziness, or you may say I'm trying to save time. So let's say 257. So now I'm going to typecast. Now this doesn't fit into a byte because 127 is the max. So what would be the outcome is, let's find out. So it's 1. The reason for this is it will overflow. Each time we reach 127, the value will overflow twice, which will end up assigning 1 to it. Okay, if you have studied the binary numbers in the beginning of the class, you should be familiar with this. And then finally, I'm gonna do this. So this is all those trees, B1, B2, and B3 are bytes. So here's what I want to do. I'm gonna say B2 is 10, B3 is say 30, and I want to say B1 is B2 plus B3. Now here's my question, can I do this? You might say those values are not too big, so 10 plus 30 is 40, still in the range where the byte can support. However, can I do it or not is my question. So let's see if we get anything funny. Yes, we have a problem here. So this incompatible types possibly lossy conversion from int to byte. So there is no int here. You might say, where is the problem here? The problem here is, even though B2 and B3 are bytes, Java does not do any operation, any arithmetic operation on byte level. What it does is it actually converts this to an integer and converts this to an integer, and does integer level addition, so the result will be an integer. So even though it seems like it's perfectly fit in, but actually that will also require typecasting. Okay, so then I can say this out. Way to go. Oops, I need to. So the value of B1 is 40. Again, even the values themselves are bytes, perfectly compatible. However, Java does not do byte level operation, it does integer level. So there is an automatic typecasting here. So 10 is converted to an integer 10, 30 is converted to an integer 30. Add them up is an integer 40, which is a 32-bit data type.